In the last video, we saw that we could take a system of linear equations like so, and we could graph them and find their solution by looking for the point where the two equations intersect. That leads us to a question, well, what are all the possible ways that two equations can intersect? For instance, these are two lines that we're talking about, and I want to know how many times, if at all, these lines intersect. So in red, let's go ahead and graph the first line, y is equal to x plus 1. So here is our y-intercept there, and our equation has a slope of 1. So we'll go ahead and put our next point there. And let's go this way, there. And we will say that our line looks something along that. Looks a little bit something like that. Not perfect, but you get the gist of it. Well, our blue line is y is equal to negative 1/2 x minus 2. So it crosses the y-axis here at negative 2. And I'm going to go up and back, positive and then negative. So I go up 1 over 2, and I have another point there. So these two lines will cross right at that point there. Right at that intersection point. Right here. And that point is negative 1, 2, negative 1. So the point where the solution is, let's do that in a better color. The solution is negative 2, negative 1. And in fact, let's see if that's true. If I say, is negative 1 equal to negative 2 plus 1? Well, tally-ho, it sure is. What about over here? Is negative 1 equal to negative 1/2 times negative 2 minus 2? Let's see, negative 1 is equal to negative times a negative is a positive, 1 minus 2. And sure enough, that is also true. As you can see, these two lines intersect at one and only one point. And I want you to notice that the slopes here are different numbers. One, my m is equal to 1, and the other, my m is equal to negative 1/2. And I want you to tell me something about the nature of the solutions to a system of linear equations when the slopes are different. Let's take a look at another system. This system has two lines, 3y minus 2x is equal to 6. This one says negative 12y plus 8x is equal to negative 24. So let's do this. Let's draw an xy chart and see what happens when we use our x is 0 and solve for y. So when x is 0, divide both sides by 3, and I get that y is equal to 2. So x is 0, y is 2. So I'll put a point at 0 and 2. 1, 2. I'll put a point there. And let's try when y is 0. So those cancel, and I have to divide now by negative 2. Divide by a negative 2. And so then when y is 0, x is negative 3, is it not? So let's say when y is 0, x is negative 3, so we'll go 1, 2, 3 over here. And we have a line that goes through these two. All right, and let's do an xy chart over here because it's the same. You know, both of these numbers are divisible into negative 24. So let's see what happens when x is 0. When x is 0, those go away. And then I just divide both sides by negative 12. And oh, that's interesting. When I divide negative 24 by negative 12, I get 2. So my blue line also has a point at 0, 2. It's got a line there, huh? Well, that's pretty weird. Well, let's try y is equal to 0. So when y is equal to 0, those go away. I divide both sides by 8, so divide that by 8. And interesting again, I get a negative 3. I have a blue point there. And my line essentially is the same line. It's the same line. So when this happens, when I have the same line, it doesn't matter what point I choose on the equation. Notice they will get the same result. So when my lines are the same, I am said to have all solutions. So everything that will work for this equation will also work for that equation. And that'll happen. Tell you what, why don't you solve both of these for their slopes and take a look at the slope and the y-intercept and let me know how that works out for our conjecture here. Finally, let's take a look at two different lines. F of x is equal to negative 3x plus 5, so it crosses at 5. 1, 2, 3, 4, 5. That'll be our red one, isn't it? Should be our red one. 1, 2, 3, 4, 5. And it goes down 3 and over 1. So I have a line that goes something like that. Well, our blue line crosses at negative 2, so 1, 2, and it also goes down 1, 2, 3, and over 1. So it looks a little bit something like that. And what can we see about these two lines? These two lines are parallel. And as parallel lines, they will never cross. And so they are said to have no solutions. And once again, I would like for you to tell me a little bit something about the slope and what it predicts about the nature of the solutions to your system of equations.